A particle is thrown at a velocity of 30 meter per second and with the angle is 45 degree, and it lands in a ditch 10 meter deep. So we need to find, this is 10 meter, we need to find how long it takes to reach there, and then how far it lands, so this distance. So first, in order to find the time, how long it takes, we can think of this time and this time separately and add them. So this is the maximum height, and at the maximum height the velocity becomes 0. So Vy is equal to Uy minus Gt, and in that formula this one becomes 0. So T, that is the half of this full, so this one is half of this full time, so we know that. And this one Uy is the 30 and sine 45 degree, and over G, G is 10 probably. We need to use 9.8 G, the actual value, 9.8 meter per second square. So yeah, say point there. Anyway, so that one there, so this one becomes 30 sine 45, which is times 1 over root 2, and then this one is 9.8. so that's the half of the time. So the total time will be twice of this one, 30, and then 9.8 times root 2, so that's 4.34 second. So this time is this much, and then we have to see this time, how much is that. Now here the velocity is downwards, and the velocity will be just like what it was here, so it will be 30 sine 45 degree, the downward velocity. And if we use this formula, h is equal to ut, now the acceleration is downwards and the motion is also downwards, so we will have to use plus gt square, and this is uy. Now h is 10 because it's given, this one is 10, and uy is 30 sine 45 degree, and t is the unknown here, plus half 9.8 t square. So that's 10 there, 30 times 1 over root 2 t plus 4.9 t square. So that's 4.9 t square plus 21.28 t minus 10 is equal to 0. So here it's a quadratic equation and t is the unknown, so we can use the formula t there, and 2 times 4.9 is 4.9 minus b 21.28 plus minus b square minus 4ac, 4 into 4.9 into that one is c is minus 10, so that's minus 10 is plus there times 10, so like that. So that becomes minus 21.28 plus 25.47 over 2.49 plus minus. So the minus we can ignore because the time will become negative, which won't. So we can take just the plus one, which is 25.47 over 2 into 4.9, which is 0.428. So this is the other time. So the total time will become, this one was 4.34 plus 0.428, so 4.34 plus 0.428 second is the total travel time. So that can be written as 4.8 if we take just 1 after decimal, 4.8 second. So that is the time when it will land here, so the total time. In order to calculate how far away it lands, we can do x1, which is this one, it will be ux and then time t, if we write the big T, so that's u cos 45 degree, and time is 4.34, so that one is u is 30 cos 45 degree times 4.34. So that one becomes 92.3 meter, and the other time is other distance is this one. So that again we can do similarly. We can do x2, and that will be the same. Actually the horizontal velocity is same, 45 degree, and that time which is 0.428. So basically it's the same thing, 30 cos 45 degree times 0.428, which is 9.1 meter, and the total distance will be 92.3 plus 9.1, so 92.3 plus 9.1 meter, which is 0.4 and then 101 approximately, that's what it comes, meter. So this much far away it will fall. That means this distance here, if I use another color maybe, this distance is 101.4 meter.